Okay, for Algebra 7.3 notes, we're doing more multiplication properties of exponents. I apologize, your notes should be in better shape than mine. Mine didn't print very well, so a little bit of this I had to write in and kind of go over, but it should be bold enough on your own packet for you to see without a problem. Okay, so essential understanding, you can use properties of exponents to simplify a power raised to a power or a product raised to a power. So what that means is, here's an example. You can use repeated multiplication to simplify a power raised to a power. If we have x to the fifth and we have all of this x to the fifth raised to the second power, that means we have x to the fifth twice. So that equals x to the fifth times x to the fifth. And remember in a previous lesson that if you have the same bases, you can add their exponents. So x to the 5 plus 5, which is x to the 10. So an easier way to do it would be if you have a power raised to another power, you just multiply those and you've got x to the 10th without having to think about them repeated. So if you have one base and it's raised to a power and that whole power is raised to another power, the exponents get multiplied. Please don't confuse that with when the bases are separated out and they're the same base and you can add their exponents, because adding is different than a power raised to a power that gets multiplied. So let's practice a few of these. So if you had, for example, a to the m power and that whole thing is raised to the n power, then m and n can get multiplied. So a to the mn. And that's just an example. So here's another one. 5 to the fourth raised to the second, 4 and 2 would get multiplied, which would make it 5 to the power of 8. M to the third raised to the fifth, 3 and 5 get multiplied. That'd be m to the 15th. Okay, this one's a weird one, and I had to write over it in pencil because my printer didn't copy very dark, but this is a to the 3 over 2. So that's a radical exponent, 3 halves. That whole thing raised to the third power. So these still both get multiplied. And if you remember how to multiply fractions by whole numbers, you're really just multiplying the top and the bottoms. And this bottom has a hidden invisible 1. So the top is 3 times 3, which is 9. And the bottom is 2 times the hidden invisible 1, which is 2. So that equals, that should have been an equal sign, a to the 9 over 2. Same thing here, x to the half raised to the 3/5. You can just multiply the tops, multiply the bottoms. So 1 times 3 is 3, 2 times 5 is 10. So x to the power of 3/10. Okay, so let's try one of those. N to the 4th power raised to the 7th power. Remember, 4 and 7 get multiplied, so that would be n to the 28th. Okay, this one is a radical, x to the 2/3 raised to the 1/2. So the tops get multiplied, so that'd be 2, and the bottoms get multiplied. 3 times 2 is 6. The only problem is you do have to simplify. So 2/6 is the same thing as 1/3. Okay, if you got it, I would like for you to pause the video and go ahead and try these 4 on your own. If you are not quite ready to try it on your own, I can work it out with you, or if you're just checking your answers, here we go. P to the 5th raised to the 4th would just be p to the 20th. P to the 4th raised to the 5th, just looks like we swapped those spots, but 4 times 5 is still 20. Okay, this one says p to the half raised to the 1/4. So that would be multiply your tops, multiply your bottoms. That would be p to the 1/8. And did they just do that same thing to us again? Yes, they just flip-flop the spots. So once again, p to the 1/8. Okay, our next section is simplifying an expression with powers. So this time we do have a power raised to another power, but then we've also got just this other exponent out front. So let's not worry about that one for now. Let's worry about going ahead and multiplying the power to a power. So we're going to start by, I'm just going to keep y to the third, y to the third. But y to the 5 halves times -2, these two can get multiplied. And remember, the tops get multiplied and the bottoms, which this is a hidden invisible 1 down here. So 5 times negative 2 is y to the negative 10 over 2 times 1, because that's the bottoms, the denominators would just be 2. Okay, so let's simplify this first. So we've got y to the third, and then if you simplify that, that's y to the negative 10 divided by 2 is negative 5. Okay, now we've got bases that are the same. Remember this from a previous unit, so you can add exponents. So 3 plus negative 5 makes the entire answer y to the negative 2. But the problem is, okay, that irritates me that I went from straight y's to a curved y. Whatever. Sorry. The problem is you can't have a negative exponent. So just when you thought you were done and I was going to circle it, a negative exponent has to flip to the bottom of a denominator under a 1. So this is y on the bottom. Now I went back to a straight y. I like that. And the negative, because it goes to the bottom, becomes positive. So the final answer is actually 1 over y squared. Okay, that was a lot. If you think you got it, go ahead and pause the video and try the next 3 on your own. And if you're not quite sure, I will work them out with you. All right, let's try these together. So these are hard to see. X squared is going to just stay x squared for now. I'm not going to worry about that. I'll bring it down and deal with it later. X to the 6th raised to the negative 4th, these get multiplied. So that would be x to the negative 24th. All right, these bases are the same. When the bases are the same, you can add their exponents. So that would now be x to the negative 22. Can't have a negative exponent. It's going to flip to the bottom under a 1 and become positive. Letter B. What is that supposed to be? I don't even know. I think it's 5/3. So we're going to say, we're just going to not mess with the w to the negative 2 for now, but 5/3 times the power of 3. So remember, 3 is like 3 over 1. So the tops are 5 and 3, which is 15. And the bottoms are, I think that's a 3 times a 1, which is 3. Okay, let's simplify that. So we still have our w to the negative 2, and this is going to be w to the 15 divided by 3, which is 5. All right, now they're the same base, so we can add negative 2 plus 5 is 3. W to the 3rd power. Okay, what do we have here? This time the power raised to a power is our first set. So we're going to do s negative 5 times negative half. So that's like saying negative 5 over 1. So let's multiply straight across, straight across. It's a negative times a negative, so I know it's going to be a positive. 5 times 1 is 5 in the numerator. 1 times 2 is 2 in the denominator, and it's a negative times a negative, so it's positive. Okay, let me bring down this guy. That's s to the, I think it's 3 over 2. Okay, since these are the same bases, you can add their exponents, and if you forgot how to add fractions, the denominator has to be the same, and then all you do is add the numerator, so it'd be 8 halves. But let's say I forgot. Let me just remind you how to use your calculator to figure out fractions. I need to add 5 halves plus 3 halves. So 5 on my calculator, it's the ABC button, 2, plus 3 ABC button, 2. And that is 4. So it was 8 over 2, but we know that 8 over 2 divides to be 4. So technically, if you were working this out, you would have got 8 over 2 first, but 8 divided by 2 makes it s to the 4th power. Okay, let's go to the next page. So the next page is raising a product to a power. The words are, to raise a product to a power, raise each factor to the power, and then multiply. Here's your example that is, again, really hard to see. Sorry. It says, in parentheses, ab to the power of n. means A gets the power of n and B gets the power of n. It's almost like they get distributed. So it would be A to the n, B to the n. A and B can't be equal to 0. N has to be a rational number, which for our purposes will do all of that. But I really want you to see that the little n, if it's outside of parentheses, it's going to go to both. It's going to be the exponent to both parts, both bases. Okay, so let's look at this one that I kind of tried to fix. In parentheses, 3x to the fourth power means 3 gets a fourth power and x gets a fourth power. So x to the fourth is going to stay x to the fourth because we don't know what x is. But 3 to the fourth, you can tell me what 3 times 3 times 3 times 3 is, and it's 81. So this is the final answer for that one. This rational one that is super hard to see, here, I'm just going to rewrite it. It was 4b to the power of 3 halves, maybe. This is not what your paper says. I'm sorry, guys. Okay, the 3 halves is going to go to the 4 and to the b. So it's going to be 4 to the 3 halves, b to the 3 halves. And you can actually work this out. This part, b to the 3 halves is going to stay b to the 3 halves because we don't know what b is. But 4 to the 3 halves, remember we did this in one of the previous lessons. I'm just going to do it on my calculator. 4, my raised to the power button is this caret key. So to the power of a fraction is 3 halves, so 3 ABC2 equals 8. So this is going to be equal to 8b to the 3 halves. Yep, and that's the answer they have right here. It's just hard to see. Okay, the next section, we have a multiple choice problem. It's simplifying a product raised to a power. So which expression represents the area of this square? It's been a while since we've done area, but area is length times width. In this particular case, it's a square, so the length and width are the same. So you could just take the entire thing and square it because length and width are both 5x to the third. So you can either write it like this, or you can write 5x to the third times 5x to the third. So that's the same thing. So since I've got 2 of them, you can, in fact, this way we did yesterday, so we don't really need more practice on that. You would multiply your coefficients first and then add exponents when the bases are the same. But I want to do it kind of the way we learned today. You would take your little 2, your squared, and basically I'm just going to use the word distribute it to both sets of bases that are inside the parentheses. So 5 is going to get the squared, and x is going to also get the squared, but these 2 get multiplied because it already had a 3. So 3 times 2 is 6. And then remember, you can go ahead and solve this. 5 squared is 25. So your final answer is 25x to the 6th. And since it was multiple choice, here we go, D. Okay, it is time for you to do a few of the got it's. So push pause on the video and try those 3 if you're ready. If you are not ready, or if you just want to check your work, let's do this together. So 7m to the 9th, you've got a 3 raised to the power of 3 on the outside of this whole set of parentheses. So this 3 is going to go to the 7 and to the m to the 9th. So it's going to look like this at first. 7 to the 3rd, m to the 9 times 3, which is 27. And you're almost done. You just need to solve what 7 to the 3rd power is. And I'm going to put it in my calculator, 7 to the 3rd power, or you could do 7 times 7 times 7, is 343. So the final answer is 343 m to the 27th. All right, let's try B. -4 goes to the 2, and it goes to the z. So we've got 2 to the -4th, z to the -4th. Okay, let's remember you can't have negative exponents. So both this term and this term are going to flip to the bottom under a 1 as a numerator. Then it's going to be 2 to the now +4th, z to the now +4th. And the only thing left to do is you can tell me what 2 times 2 times 2 times 2 is. So you can either type it in, or you can do 2 to the 4th power in your calculator. to get 16. So the final answer is 1 over 16 z to the 4th. Okay, last one of these. We have a -2 to distribute to each of the bases. So -2 goes to the 3, and the -2 goes to the g to the 4th. So at first we have 3 to the -2, g to the, these get multiplied. 4 times -2 is -8. However, you can't have negative exponents. So both of these terms are going to flip to the bottom under a 1 and become positive. So now it's 3 to the +2, g to the +8 on the bottom under a 1. And the last thing is, you can tell me what 3 squared is. 3 times 3 is 9. So the final answer is 1 over 9 g to the 8th. Okay, let's move on. We're getting closer to done. Problem 4 is simplifying an expression with products. So you have n to the half raised to the 10th power times 4mn to the -2/3 raised to the 3rd power. Whew, that's a lot. Okay, I'm going to start with just the n to the half to the 10th, and this is all getting multiplied together, but I'm going to do this little part first. So remember, 10 is like a 10 over 1, so it is going to be n to the 1 times 10 is 10, 2, I think that's a 2, times 1 is 2. So just with this part alone, I have n to the 10 over 2, which is 5. N to the 5th power, because 10 divided by 2 is 5. So I've got n to the 5th power. I just don't want to get confused. Okay, next I have this tiny little 3 exponent out here that needs to be distributed to the 4, to the m, to the n to the -2/3. So I have 4 to the 3rd, m to the 3rd, and then let's go ahead and distribute the n to the -2/3. Remember, that's like 3 over 1. So -2 times 3 is -6, and 3 times 1 is 3. And we're going to have to simplify that. So let me just go down below it. We have n to the 5th, 4 to the 3rd, m to the 3rd, n to the -6 divided by 3 is -2. Okay, let's look through here and see if we have any bases that are the same. I see an n and I see an n. So if you have bases that are the same, you can add their exponents. So I also want to move this coefficient out front. Coefficients always go to the front, and I can solve it while I do that. So 4 to the 3rd is 4 times 4 times 4. So 4 to the 3rd power is 64. So I want to go ahead and move the 64 out front. And I'm just going to cross it out as I go because I'm going to get really confused here. Alphabetically, m comes before n. So I'm going to use my m to the 3rd next. And then I'm going to add the exponents for our like bases. So 5 plus -2 is 3. So n to the 3rd. And that is a big problem. I am ready for you guys to try these 2 that are like that on your own. If you are ready, push pause on the video, and if not, I'll work it out with you. Okay, these 2 get multiplied. So x to the -2 times 2 is -4. This little 4 gets distributed to the 3 and the x and the y to the 5th. So that's going to be 3 to the 4th, x to the 4th, y to the 5 times 4, which is 20. Okay, 3 to the 4th is my coefficient, so I want to write that out front. So 3 to the 4th is 3 times 3 times 3 times 3, which is 81. So 81, and I'm going to cross it off because, again, I'm just getting confused on what I've used. Alphabetically, x comes before y. So let's add my x's. -4 and +4. -4 plus +4 is 0. And if you remember what x to the 0 power is It's 1. So 81 times 1 is just going to be 81. So I can actually just cancel out all of those. And it leaves me with y to the 20th. So that problem is done. Okay, B, I see a 4 here that's going to go to the 3. And it's going to go to the c to the 5 halves. So we've got 3 to the 4th and c to the 5 halves times 4 over 1. 5 times 4 is 20. And 2 times 1 is 2. I know that's going to change to be a 10, but let's just keep going for now and go ahead and distribute this. These get multiplied. So c to the 2 times 3, 6. Okay. 3 to the 4th power, didn't we just do that? Yeah, 3 to the 4th power was 81. So we've got 81. C to the 20 divided by 2 is 10. And then we've got a c to the 6th. These are like bases, so we can add their exponents. So our final answer is 81 c to the 10 plus 6, which is 16. All right, last section is scientific notation. I'm not sure if you guys learned this in actual science class, but because it is part of the pre-algebra curriculum, we need to fill it and make sure that you guys know how to do it. Since you did not have pre-algebra, you're skipping straight to algebra. So here's what happens. When you have an expression 3 times 10 to the 8th power and it's raised to the 2nd power, you need to basically give that 2 to the 3 and to the 10 to the 8th. So this would look like 3 to the 2nd power times 10 to the 8 times 2, which is 16th power. So then when you write it, it would look like 3 to the 2nd power, which is 9, times 10 to the 16th power. And that is scientific notation because your first number is between 1 and 10. So this is how you would do that. Otherwise, you need to look at how you need to move the decimal, and that would cause you to change your exponent as well. I think we have a few of those examples just to remind you how to do that. So let's try number 5. You would give a 2 to the 4 and a 2 to the 5 to the 10th. So 4 gets squared and the 10 to the 5th gets squared, which is 5 times 2, which is 10. Okay, so let's write out that answer. 4 squared is 16. That's a problem. You can't use 16 in scientific notation. It's bigger than 10. So we're going to have to drop a decimal at the end, move it back one place, making this number smaller, which means we need to make our exponent one number larger. So the final answer would be 1.6 times 10 to the 11th. All right, let's try this one. So the 5 goes to the 2, so 2 to the 5th power, times 10 to the negative 3 times 5, which is negative 15th power. All right, 2 to the 5th power, I don't know what that is, so we're going to put it in our calculator. 2 to the 5th power, 32. Too big. Can't use 32 in scientific notation. So we'll fix that. So if you're going to drop a decimal at the end and make this number smaller, making it 3.2, you're going to need to make your exponent one number bigger. So closer to 0 would be to the negative 14th. Okay, it is time for you to press pause and try this. Got it is up really high. It was supposed to be for this section. So push pause and try these 3 on your own, or I can help you if you want to let the video play. Okay, I'm going to go through these a little quicker. Give the 2 to the 3. Give the 2 to the 5 to the 10 to the 5th, which would be 5 times 2, which is 10. 3 squared is 9 times 10 to the 10th. There is nothing wrong with 9. It's between 1 and 10, so it's done. All right, give the 5 to the 4. Give the 5 to the 10 squared, which means 2 times 5, which is 10. 4 to the 5th power is going to be big. 4 to the 5th power, too big. 1,024. Okay, 1,024. times 10 to the 10th. That's a big problem. You're going to have to drop the decimal at the end and move it way back. You're going to have to move it 1, 2, 3 decimal places back, making this 1.024. And if you move it 3 places smaller, you're going to have to make this 3 numbers larger. So this is going to be times 10 to the 13th power, because we move this, making it these decimal places, every time you move it, it's by a power of 10, which is why we change this power of 10 to larger. And anything bigger than 1 works. So 1.024 is right. Okay, last one of these, you're going to give the 3 to the 2, so 2 to the 3rd, times 10 to the 3 times negative 10, which is negative 30. All right, let's work this out and see. 2 to the 3rd power is 2 times 2 times 2, which is 8. Good, we're not going to have to change it because 8 is fine. Times 10 to the negative 30th. I wish there would have been one example really quickly. Let me tell you, if this number is too small, let's say we got, here, this is just an extra example. Let's say we got a number like 0.0, actually, that wouldn't work, 0.002 times 10 to the 10th or something like that. So if you're needing to make the number bigger, you're going to have to make your exponent that many times smaller. So if I needed to move it to the right 1, 2, 3 places to make it 2, you would need to move this number down 3, so it would be to the 7th. So I hope this extra example, because of your Math Excel, makes sense. Okay, last section I kind of added on here because I think you might need more practice problems like this for your Math Excel. You might be okay, so if you want to skip this section, you can if you think you're all good. If not, let's just work out these last 3 together just to make sure that it is going to be good for your Math Excel. So these numbers get multiplied. When you're multiplying fractions, you go straight across, straight across. So we've got x to the 1 times negative 2 is negative 2 over 3 times, is that a 5? 5 maybe? 15. Here's the problem. Can't have a negative exponent, even with a fraction, even with a variable. So it's gonna, the whole thing's gonna flip to the bottom under a 1. So this looks weird, but you're gonna have a 1 over now an x to the positive 2/15. So you've got like a fraction within a fraction, but that's okay. That is actually the answer that they want you to do. All right. I've also, yeah. You're going to put it like that. I was going to say I've also seen it a different way, but I think that's how Math Excel wants it. Okay, number 2, these get distributed or multiplied, sorry. So it's m to the, remember that's like a 3 over 1. So 3 times 1 is 3 on the numerator. 1 times 2 is 2 on the denominator. 4 times 0 is just 0. N to the 0 power, anything to the 0 power is just 1. So this whole thing times 1 means it's just this whole thing. So that one is actually pretty quick, pretty easy. Okay, last one. Remember, if it's a set of parentheses and an exponent outside, you have to give that exponent to all the terms. So it's going to go to the 3 and to the y to the 1/8. So 3 to the negative 2, y to the, these are going to get multiplied. So straight across, 1 times negative 2 is negative 2. On the bottom, 8 times 1 is 8. So the problem here is, oh, I guess we could simplify this first. So if you want, we can go 3 to the negative 2, y to the negative 1/4. Okay, you can't have negative exponents. So both terms are going to have to flip to the bottom under a 1, and now they're going to be positive. So y to the positive 1/4. And the last thing is you can actually work out what 3 squared is. 3 times 3 is 9. So this is going to be 1 over 9y to the 1/4. So again, you've got a fraction within a fraction.